Alright, we're back. I hope that first part wasn't too boring or too technical. Anyways, I demonstrated the effect of the magnetic shielding, which is very real, very there, and it works. But you put a stack of magnets like this on that coil and it ain't gonna let go. So we're left with a bit of a conundrum as to how, let's say, this particular motor with much more powerful magnets on the rotor seems to work so well when the magnetic shielding is not going to let go of those magnets so that they just fall away. Just imagine, I mean, if you put a lot of power into them, they might do it. They might fall away, but we don't want a lot of power required to do that. What we want is the minimal amount of power. So now we're looking at, again, geometry too. Another thing I wanted to demonstrate to Ed here, if I have a, let me just run and grab a core here. Now you can see how my magnets are turned sideways. We've got north and south, north and south, north and south, north and south, north and south. They're all oriented the same way. So here's the Hall sensor. Ed, you were asking this before in a post. Where's your Hall sensor? What's your timing? Well, the way this thing is set up here, if you can see it, I'll try and zoom in a little bit here. Okay, it should be close enough. Our Hall sensor is placed right here. Oops. Right here, right on top of that toroid coil, which is probably, I will definitely say, 100% not the right place for this particular setup. At least I'm pretty sure about that. I have other Hall probes that I use that I can, I can even disconnect this one and just hand hold it in different locations to find the best timing position. But normally what I have is, and I got to drill some new holes here for Hall sensors. I had one on this side at one point, and I had one on this side, which was just a little bit before this coil here, so I would call that like before top dead center for this coil. So before top dead center here is not really going to work all that well for this coil, for this magnet and this coil here, is it? Right? So what we have here is, I don't know if you can see this, but we have something like this. Okay, let's zoom out, back out. Okay, so geometry wise or physics wise, we've got the core sitting like this and the magnet coming along like this. So you've got a very strong attraction to the side of this thing, right? Whereas if the magnet was this way, it only sticks there but not here, and it sticks there, right? So in my opinion, it works better if you can get that magnet pulling to the side of the core rather than the center of it, where there's a big hole in the middle. So yeah, that was another thing I wanted to point out as far as geometry orientation, stuff like that goes. You'll also notice that this magnet, and I don't know whether it was just dumb luck, but let's not overthink this thing. I mean, there's been talk about guys cooking up some kind of algebraic or algorithmic formula to figure out the best scenario to make this thing work. Well, I don't know whether it was just dumb luck or whatever, but these are the parts that I bought. You know, a core that's about, you know, a ½ inch inner diameter. The magnets are 3/4 of an inch long, quarter of an inch diameter. That's just what I started with, and I just went with it, and this is what became of it. This is what came out of it. I've only experimented so far with different numbers of drive coils, different numbers of magnets on the rotor so far. The next thing I'd like to do, now that I've got, you know, made Ed happy by harmonizing all my coils here and having the same types of coils in the whole system here, and the way they're wired right now, one set of windings starting here, going to there, to there, to there, to there, to there, is in series, and they are driving the motor. The other set of coils, or the other set of the other winding, goes from here to here to here to here to here to here. It's all in phase. Inner winding coming out to outer winding, inner winding in, outer winding out, inner winding in, and it's the same for the secondary inductive coils, the secondary windings. It's all the same. So now that that's straight, anything that I do from this point forward and show in the video and scope measurements and all that stuff will be under those conditions. So anyways, there you go. You can see, you know, that magnet is almost, it's a perfect width for this core. So I'm guessing, you know, just offhand by chance, this was the right pick, right? This was the right geometry to use, you know, for this little adventure. So anyways, I'm gonna fire this thing up here, get it going, and we're gonna talk about helper magnets. Oh, the thing won't run because I disconnected the drive coils. Now, it's, as you can see, running quite slowly. Not very fast at all. I can't show you with the camera because it's on the boom right now, but it's drawing about 115 milliamps rising. It's up to 120. Doesn't seem to be doing very well. Oh, well, that's probably because I'm only running at about 9 volts. So, before we go any further here, I'm just going to power down, disconnect the drive section, turn the power back on, reset the voltage back up to just over 12. Let's go up to about a little higher than that. Come on. Come on. 12.84, good enough. Reconnect the drive, which is that wire that's comes off of here. Ed, pay attention now. Coming off the MOSFET into the first drive winding, out of that one to the next one, out of that one to the next one, next one, next one, and back to here. Simple for the drives, okay? And that was the way it was before, except that these three were single winds, these three were double winds. So all I've got is 3 extra double winds, so in theory, guess what? I should be able to generate or induce a little bit more juice, and it might affect the motor's performance. Well, I'm saying it's probably, I won't say might, I say it will affect the motor's performance. So, let's get it back on again. It's going to take a while to spin up. And as you can see, it's really pulling the voltage down. I have it set to the power rail was set at 12.8 volts without a load on it. Now look at how low Look at how much pulling down the current's pulling that voltage down, and as the thing speeds up and gets a little, you know, a little bit more RPMs and stabilizes itself a little bit, well, you know, you can see it's already gone up somewhat to 11.2 here, 11.3, 156 milliamps. Not really running all that well, is it? So we're going to get the old helper magnets out here. And first things first, with the single wound coils, or at least, yeah, with the single wound coils, I found that I needed I believe it was a north pole facing towards the core. I'm going to get my compass here. Now, according to this is the south pole, and I had to reverse them all from north to south in order to, because if I put a, well, I'll show you. Here's the south pole. We've already got increase in RPMs. Current went up a little bit, but I'm sure it'll stabilize a bit. Yeah, it's already coming down below 200. So, south pole. Let's take this puppy here. That's the, yeah, that's the south. Well, here's a, that's the south. Repelling. Okay, here's the north. Oh, dear Lord. The current went way down. Probably because the RPMs have gone down, but it just killed the motor. I'll bet you it won't even run. Yeah, see? I wonder how we can explain that. Alright, so let's get the proper polarity on the magnets here. I'm only going to put two on right now. One here. Let me give this a little bit of help here. Now we want another. What did I do with my compass? Oh, for crying out loud. There's the compass. So we've got, this is the north pole. So let's try north pole over here. Oh no, it doesn't like that. It just does not like that. So we've got a south pole, another south pole. Oh, likes that. Now that's only two helper magnets. That's a considerable increase for just two. Current's come down to, it's coming down towards 100 milliamps. Our voltage has gone up to closer to where it should be, 12 volts. You can take a quick little reading for the RPMs if you wish. And we have just over 1,600 RPMs. Now I don't have the secondaries wound or connected in any way. That's just the drive coils. I'm going to turn the scope on now, and I'm going to have to take the camera off of the what do you call it? Boom. But I want to show that the way it is now, we have a very, very nicely reflected I'm just gonna take this off of here. Okay, we got that. That is, you can see, I'm gonna zoom this out, I think. Is it already zoomed? No. Yeah, it's already zoomed out. That is the drive coil. That's the signal coming off the MOSFET going into the coils. Into the coils, that's it. 60 volts peak to peak, and it's looking like it's about 870 hertz, which is actually, that's quite high for the RPMs. Anyways, I'm going to switch the probe. Now watch this, Ed. The probe is coming over to the secondaries. The ground has, well, see, the ground actually looks kind of interesting. It shouldn't. see the other end of this wire? That's the other end of the secondaries. It's plugged into 0, nothing. There's 0 here, there. Okay, it's unplugged. We're still getting a reading off of the secondaries, which is almost an absolute mirror image of what's coming off the what do you call it, the MOSFET driving the damn motor. But I've got 3.5 more volts peak to peak all of a sudden, and about the same frequency, and you can see some little spikes going on there. So let's connect the ground, okay, from the scope to the other side of the secondaries, okay? And we get almost exactly the same thing, but now we're getting almost 70 volts peak to peak. Lots of harmonic ringing in there. But that looks a hell of a lot better than what it did before, because before it was just a bloody staticky mess. I'm not sure why. I don't think it's because I just added 3 more sets of secondaries, or three more secondary windings. It's not because it was out of phase, because I made sure it was all in phase, because if it's not in phase, you get squat. You get a really piss poor you know, peak to peak voltage. You get nothing. The current has stabilized out at about 102, voltage at 12, under load, set it at 12.8 without load. Now, the next thing we can do is add another set of helper magnets, but I'm going to have to, yeah, you see this is north, this one here, north orientation here. So if I put that, oh wow, look at that, it likes north there. Well, would that be the same? Yes. Interesting. So we've got a little bit more speed increase, the currents come down, voltages come up somewhat. We've got a little less peak to peak voltage on our secondaries though, so let's take that away. It's gonna maybe creep up just a little bit. But that's interesting. This should not be happening. This is the north. I thought they all had to be switched to south. Let's try a north over here. A little bit of an increase. North over here. A little bit more increase. Not very much, but it seems to like it here. And I have to hold that there because I don't have a little keeper tab for it. So what I'm going to do, I'm going to pause here for a second and glue some pieces into place, like these little tabs here. You can see this little wooden tab that holds the edge of the tube holding the magnet from flying into the rotor, which it will tend to want to do because it likes the magnetic attraction. So you can see I've got one there. But since I've changed out my towers, I've got these shorter towers that have slightly smaller bores in them to hold the bifelar winds, because they turned out slightly less diameter than my original tower holes, so put a little tape around them like you can see on that one. That's these two towers, number 4 and number 2. I have to use those because I only have 4 short ones and I've only got 4 tall ones. And as you can probably see over there, that tall tower is a little bit too tall to, it's holding, this core should be down a little bit. You can see the other ones are lined up better, obviously, right? So there you go, there's another, geometry issue. So yeah, I'm going to pause for a minute and set up some little sticky things so I can put up my helper magnets without having them fly into the rotor. And it looks like my battery's dying, so I'm going to have to recharge, and we'll catch you on the flip side. Alright, as you can see, I'm back here. Still got a bit of a battery issue here, pretty quick to recharge. But anyways, as you can see, I have put these little pieces of wood here to keep the magnets from flying into the rotor. So now, as you can see, I've got 4 helpers on there. Voltage is at 12.6, which is only 20 milliamps, or slightly higher than what the unloaded source is. 75 milliamps, 75.5 milliamps for the current draw. And you can hear, obviously, that the motor is running somewhat faster than it was before, so we're going to take a RPM measurement here. There's the boom I was using, just in case you're curious. Now, hopefully we can get a beam in there, and can't probably see that, can you? I would say that reads 1920 RPMs, and it's pretty steady. So we're close to 2000. This is not very good. I've had it going much faster. But then again, we don't have this puppy connected, so we can do that. Before I do that, you know what? I'm going to power this thing down. I don't want to blow up another sensor. Just turn everything off and be safe here. It goes into the positive power rail. Okay, right? Positive back to VCC. The other side of the cap off the steering diode. Right there. Okay. Now everything is connected back into here. Okay, now right now the secondaries are still not connected to anything except the scope. This capacitor is being fed into the power rail on this board here, which is going to power that load. So if I start this thing up, we should get some lights. And we are not. Why? That's there. Oh, okay. That's because there's no negative to, yeah. Do I have to ground that? Give me a second here. Alright, I just wanted to show you really quick. I've got those magnets I showed you in place so that this sits right on top of it and is more or less kind of held in place. Not totally securely, but securely enough so that they don't wiggle and move and vibrate around. Obviously I could glue one of these big magnets into the base of the pipe so that it's a lot more secure, but I don't want to do that because the pipes take up too much space, and unless I redesign the engine, which I am planning on doing anyways, to have the drive coils in an axial over under the rotor as opposed to on the edge of it. And the rotor is going to look more like this, with the magnets right embedded in the side, so that a coil can be placed very, very close to the top side and very, very close to the bottom side, so we can sandwich it. And if you guys take a look at my CAD drawings in the ORBO folder under my folder, Kevin's ORBO files, you'll find some CAD drawings in there, some screen captures of the CAD files I did, which shows that sort of a design, which is based more on Doug's ORBO design, which can, you know, it's a more efficient design. You can have more coils, more magnets, more rotors. But I took it one step further. Instead of having one flat rotor surrounded by two sets of coils, I've got that sort of thing, but on either side of the two sets of coils, I have a second and third rotor over and under, you know, so you've got even more torque, pulling power. And you can keep stacking it. Just, you know, on the top side, add another set of coils and put another rotor. But I suppose to a certain extent, you know, you keep adding coils, you're going to keep drawing current. But I don't know. If you use bigger magnets, then you're going to get a lot more torque out of it. So zippity doo-dah. Anyways, that's our waveform on the drive coils, the MOSFET. Nice, stable. I've never seen it that perfect before. 400 hertz. And what are we doing? How are we doing for current here? Yeah, it's come down a bit. 23. Oh, well, I'm missing a helper magnet here. I've lost I've lost the magnet here. I don't know where the hell it got to. It stuck to something. I'll bet you anything, but anyways, I gotta put these magnets and actually add one more because I lost that one. Add one more. Stick it in the pipe. And as you can see, this helper magnet is not, because of the, if you can see that, the plexiglass is holding this little platform that holds the circuit board or whatever. That was a secondary add-on when I built all this in here. and it should have just been a flat piece of plexi, so that's another thing. I gotta cut a whole new piece of plexi. As you can see, it's full of holes, but it's still good enough for a prototyper until I get something a little bit more workable. Our voltage has come down. That sucks. Our current's gone up somewhat. It's come down. I wonder if it's just because it's at a bad angle. No. Maybe it needs more magnets, less magnets, different polarity again, who knows. Take that out of there and just use these ones. That doesn't like that, it likes that. And you can see that it's a little bit better aligned there. I just moved it down, it went down 10 milliamps. It just went down another 10 because I moved it down, down, down. You can see it's lower. Bring it up. Current goes up a titch. Now the other thing I tried one time is putting magnets right on the thing. And you can see the current went down, RPMs went down, voltage went up. Other polarity. How about if we move it back there? Current stays about 23. Voltage still a little higher than it was before. Yep. It does better without helpers on that one. Try helpers on the other one over here. Same difference. No difference. Oh, we got more voltage over there. Got an extra bit of voltage. With that, but that's right on. That's with it right on there. Current went down. RPMs went down. Well, as you can see, you can mess around with this till the cows come home. And try all sorts of different things. Some things work, some things don't. I'm still really puzzled about that. I wonder if I just hook this up to an antenna on the roof, if it would just start pulling in power from the atmosphere. Just like Tesla promised us. I suppose I could attach that to a really big honking stack of wires, like a coil. I got a big coil full of 23 gauge wire. Might act like an antenna. Maybe? What do you think? Connect this to that. Well, there's a bare wire sticking out here. I could actually almost do it. Let's see what it does. Nothing. 0. 9.3 volts. Absolutely zippo. I don't know what I thought was going to happen. Anyways, okay, I think this has gone on quite long enough. This is already a two-parter, I think. Trying to think of anything else that I could touch upon here that's going to clear things up for a few people. Nothing I can think of right now. Anyways, that'll be it for now. I might have to edit this down a bit, but I really don't want to because there's lots of stuff in here. These things are just not a cut and dry 10-minute, sound bite. This has to be explained, and if you're gonna get it, it's gonna take time. You're gonna have to sit and watch at least a good 40, 50, 60 minutes of me blabbing my mouth off and pointing the camera at different shit here to show you what's going on. Anyhow, I kind of like that effect of that, the way that light is on the camera. I can see it looks like it's streaming up into the ozone, oh, there we go. You can see it there. Yeah, kind of neat. I don't know if it's gonna be caught on film or not, but I'm gonna have a smoke now because I haven't had one for almost an hour of me blabbing. This is your unfriendly neighborhood Batman signing off. One more thing I forgot to do. It's kind of important. I'm looking at the scope again. Waveform of the secondaries. We're getting 49, just over 49 volts peak to peak at 400 hertz. And I plugged in the wire to the other side of the bridge. And the voltage powering these lights went up went from 9.3 to 13.5 almost. You can see all disconnected. Boom. Current is 23, it stayed the same. Plug it back in. Current goes up 10 milliamps. I mean, that's not a really accurate indicator because it's set on the 20 amp setting, which is not very accurate, but close enough for rock and roll. And so yeah, let's see what the waveform doesn't change, plugged in or unplugged. But we do get more voltage on the power rail. That still doesn't explain why the thing works when it's not plugged in. It's still generating voltage. It's still drawing power out of those secondaries. Of course, it's induced by the drive coils. It's not being generated by the magnets, but it's there nonetheless. Oh, another thing that's we don't have a filter cap on our bridge here. There she be. Now, what's gonna happen? Let's get this correct. That's on the minus. That's on the plus. Oh, just killed it. Now it's come back up. Now we're coming back up to 13. Back up to where we were. That's kind of interesting. It was running, as the lights were running as well as they were without any ripple filtering. Now let's see what happens when I disconnect this again. 0. Absolutely zip. No change in the waveform. Oh, guess what? No change in the voltage either. So there we go. We still don't need that wire. And our current has gone up another 10 milliamps. So we're from 230 up to 250. We're still missing a helper magnet here. Where did that go? Kind of pulls the voltage down a bit. pump the current up. So obviously that particular spot is not exactly the greatest for a helper magnet. And our frequency's going up slightly here. We've got a little bit of jiggle, a little bit of instability in our waveform here. Kind of vibrating a little bit there. Might be just because it needs to stabilize the RPMs. 43 volts peak to peak. Well, the next step I guess would be to throw the 12 mag rotor on there and start looking for a new placement for the hall sensor for that and see what we can get done. Let's try a drag test on this puppy. Let's just drag this puppy down and see what happens to the current. Doesn't really change. Actually come down a little bit. Come down. The voltage is still pretty high. Still at 260. Lights are still pretty bright. Still at 260. Still at 13 volts. Hey, not bad, eh? What do you think about that there, Doug? We just need stronger magnets to give it some more torque. A couple more rotors, bigger magnets. Pancake the, horizontal the coils. Get another set going. This thing could actually do some work. All right, that's definitely it for this video. We're already at 24 minutes here. Over and out, Roger. Under. Over.